K-nearest neighbors, or KNN, is one of the simplest yet surprisingly powerful algorithms in machine learning. It's known for being easy to understand, easy to implement, and surprisingly effective, especially for smaller data sets. In this video, we'll break down how KNN works, when to use it, and some essential tips to use it well. At its core, KNN is a lazy learning algorithm, meaning it doesn't learn an explicit model during training. Instead, it memorizes the training data, and when it's time to make a prediction, it looks at the K closest examples from the training set and lets them vote. In a classification task, it picks the class that most of the neighbors belong to. For regression, it averages the values of the neighbors. Let's say you're trying to predict whether a new customer will buy a product. First, KNN calculates the distance from this new data point to all existing data points. The most common distance metrics are Euclidean, Manhattan, and Minkowski distances. It then selects the K nearest points and looks at their labels. For classification, it goes with the majority vote. For regression, it takes the average value. The choice of K is crucial. A small k can lead to noise and overfitting, while a large K may lead to underfitting. The ideal value for K depends on the dataset, but a good rule of thumb is to start with the square root of the number of data points. Always use odd values of K for binary classification to avoid ties. Scale your data before using KNN, especially if your features are on different scales. Since distance metrics are sensitive to magnitude, KNN has several advantages. It is very simple to understand and implement, has no training time, perfect for real-time model updates, works well for multi-class classification, and naturally handles non-linear decision boundaries. However, it also has disadvantages. It can be computationally expensive for large data sets, slow at prediction time, sensitive to irrelevant features or noise, and requires feature scaling like normalization or standardization. KNN is used in many practical applications, such as recommendation systems, finding similar users or items, image classification, like handwritten digit recognition, medical diagnostics, based on symptom similarity, and anomaly detection, spotting outliers in financial or network data. Its ability to work with raw data without complex tuning makes it ideal for quick prototypes and small-scale projects. Here are some tips for using KNN like a pro. Always scale your features with min-max scaler or standard scaler. Use cross-validation to find the best value of K. Try dimensionality reduction like PCA if your dataset has too many features, and use KD tree or ball tree for faster predictions on larger datasets. If speed is a concern, consider approximate neighbors or switch to faster algorithms like logistic regression or decision trees. And that's a wrap on K nearest neighbors. It may be simple, but it's still incredibly effective when applied correctly. If you enjoyed this breakdown, hit like, subscribe for more machine learning explainers, and let us know in the comments if you want us to cover naive Bayes or PCA next. Thanks for watching.